triple 0 1 0 1 1 0 1 1 1 0 1 0 1 0. Throw all those guys in a Karnaugh map, and you get okay. So now start grouping them. Well, it looks like this is a big old group of 8 because left and right are adjacent with each other. And check this out. Here's a big old group of 4 right there. So what are the, well, for the group of 8, what's the unchanging term? Well, D is a 0 there. D is a 0 there. Whoop, let me do that in blue. Sorry. So we stay together. So basically, what is the unchanging term for this? What is a single unchanging term for this 8-cell group? Looks like not D. What are the 2 unchanging terms in our group of 4 right here? Well, it looks like we've got 1 0 1 1 1 0 1 0. Then we also have 0 0 0 0 1 1 1 0. What are the 2 unchanging terms? Looks like not B, C. Not B, C is equal to our whatever it was, equals X right there. Okay? Lot easier than this chaos right here. Okay? And look how fast we did that. Karnaugh maps systemize means of minimizing sum of product expressions. Okay, let's do, what the hell, let's do another example. Let's try this guy on for size. So you can totally pause this recording too, and work on this, and then work on it together, and then restart the lecture and work on it together to see where you made some mistakes. Okay, so time to pause it would be now. Okay, so we're back, and you should follow a procedure similar to this, not exactly, but okay, first off, is this in a standard sum of products expression? The answer is no, because look at this guy right there. He is missing a B term. So using numeric expansion, our A has to be a 0, our C's got to be a 1, our D's got to be a 1, but our B could take a form of 0 or 1. So that means 0, 0, 1, 1 right there, or 0, 1, 1, 1 right there. And then what are the other binary combinations that will give us a 1? Looks like 0, 0, 0. There you go. 1, 0, 1, 1. 1, 0, 0, 1. You already got that guy. 1, 0, 0, 0. There you go. Okay. So given this little Karnaugh map, how are we going to figure it out? Okay, there's a group of 3, but that don't work. You got to have groups of 1, 2, 4, 8, 16, so on and so forth. So what I would do is I would grab this guy, and then wrap around adjacency, that guy right there. You could do this one if you wanted to, but again, it's one of those situations where an overlapping group has to have non-common ones to it, and you could add that thing to your expression, but it's not going to change anything, and you're just making matters worse. You know, the whole point of this thing is to minimize our expressions. Okay, so what are these things here? Did I mess something up here? 1 second. No, I'm looking good there. Okay, so what is this 2 cells expression here? What are the things that are not changing? Well, it's definitely A, not B. Then it looks like D is not changing. What's this guy? Well, it's definitely CD, who is not changing between these 2 cells here. looks like not A. And then for this one here, what is it? What's not changing? It's definitely not C, not D. And then it looks like not B. So summate all these things together, X equals not A, C, D, or A, not B, D, or not B, not C, not D. Okay? Pretty easy. Using truth tables, if you're given a truth table, you can easily throw this into a Karnaugh map and come up with the sum of products term. Let's go ahead and just give you some random truth table. And here we go. We got A, B, C, and X. And here's what X is going to look like for our given combinations of A, B, and C. So we're going to go ahead and put this in a Karnaugh map. How many variables is it? Well, it's a 3-variable Karnaugh map. So let's just draw a blank 3-variable Karnaugh map. Now all you've got to do is just go ahead and put your ones in there wherever your truth table is. So it looks like this guy goes there. This guy, 1 double 0, goes there. This guy goes 1 1 0 right there, and 111, he goes right there. So just go ahead and make let's make a 2 cell and another 2 cell right there where that exhibits wraparound adjacency. What is this guy? What is the unchanging values? It's A and B. Doesn't matter with C because it could be a 0 or a 1. What's this guy? What's this unchanging value? Definitely C. Excuse me, definitely not C. Definitely not C because it's got to be a 0. And now what's the other unchanging one? Not B. Okay, so what is our expression? Should be not B and not C, or AB. Lightning quick, huh? That's your expression right there. So that's the whole point of a Karnaugh map. Super fast. Get the sum of products expression. Okay, last thing I want to discuss about this is basically our don't care situations. Basically, there are sometimes invalid combos or situations that will not occur that you can either get a 1 or a 0, i.e. you don't care. You can maximize the size of a group and simplify your expression. So let's go ahead and I'm just going to draw a 4-variable Karnaugh map where I've got these values right here, a 1, 1, and a 1. I got to have those guys. And so ordinarily I would have a single 4 term, a single 3 term, but there's a bunch of don't care situations out there. I don't care about these values because they're never going to occur. So now what I can do is group this into, because previously, remember, it was 1 4 term and 1 3 term. But now I could group that 2 cell there as 1 3 term. And now I take this 8 as 1 1 term. So using our don't care situations, I don't care if that X is a 0 or a 1. I could just make them all 1s. I've maximized my group and I've minimized the number of groups. Okay, so this is a super long walkthrough of the Karnaugh map sum of products minimization. We're going to go right into Karnaugh maps product of sum minimization.